So good afternoon to all. It's 1 minute past 2. Let's start our lecture. We are uh, almost 20 students. Yeah, let's start our lecture. This would be our last lecture, my dear students, where we'll be doing input-output. Last topic for this semester, but not the last lecture. The last lecture would be next week, where we will be doing a revision of engineering programming. So make sure that you tune in for the last lecture next week. Now I'm going to share my screen. Okay. Today we'll be going to learn something new, something which you're going to implement in your assignment, which is input-output. Okay. Before I start the lecture, I would like to let you all know that Evaluate is open. Please go online and give feedback for all the units that you have enrolled in. Okay, it's important for you to give feedback. So, our lecture 10, input and output. We'll be learning about how to do basic input and output. In other words, how to write to a file and how to read from a file. Okay? We will also learn about some examples of writing into specific files like spreadsheet files. In other words, CSV files, comma separated value files. Input output in C, you have been doing it since the beginning of coding in C, since the beginning of using any kind of compiler, even Linux or Dev C++. Whenever you do a C programming, you always use a header file, which is stdio.h header file. Now, information about that header file, if you open it, it has got information for your input and output. Okay? So every time you say hash include stdio.h, you're invoking the input-output library. And that is the reason that your printf function and your scanf function work in the first place. Okay? If you have got Dev C++ on your computer, if you go to your installation and look for an include folder, in one of the subfolders, you will see the library stdio.h header file. And this header file has got information about printf function and scanf function. Remove this header file and these two functions will stop working. So, in every C program, you should have a header file, okay? And these header files represent which functions you can use in your program, okay? For example, stdio.h will ensure printf and scanf work. Math.h will ensure your pow function works, and so on. Now, we come to the main interest of today's lecture, which is the concept of streams. Okay? Now, what is a stream? A stream is a sequence of characters organized into a line. Now, when you say stream, we have got two kinds of streams, input stream and output stream. Okay? Now, wait a second. What are we talking about, input stream and output stream? Try and understand. The word input and output has got a specific meaning. When I say input, I mean reading from a file, getting an input from a file. So whenever you see the word input, whenever you see I, input, remember you are reading from a file. Because when you are reading from a file or writing to a file, you have to be specific in your program and say, hey, I'm going to read from a file or I'm going to write from a file. Just the opposite, output means writing to a file. In other words, output means to write to a file. Okay? So this can be sometimes confusing. So you have to remove that confusion just by looking at this one slide. When you see I, remember, reading from a file. When you see O, writing to the file. In shorter form, I means read. O means write. Okay? Now, standard input stream is called std_in. Okay? Standard input. Okay? And is normally connected to the keyboard. So what is the standard input device? The standard default input device is a keyboard. A standard output device is std_out and is associated with a monitor. Now, in today's world, most of our devices, especially our handheld devices, the input and output, that is the standard input and the standard output device, are one and the same, which is our display screen. Okay? But on a traditional von Neumann computer design, the standard input is a keyboard and the standard output is your monitor. We also have a standard error, the place where we generate the error. If there is a problem, there is an error, and that is also the monitor. Okay? Now, we have got input and output file streams responsible for reading and writing. Input file stream for reading and output file stream for writing. Okay? Now, printf is a normal function that we have been using since the beginning of this course. Okay? And it is responsible for outputting something on our screen, and it has got a specific format. You have been using printf since the beginning of this semester. Now, this is what the format looks like. You mentioned the function name, you mentioned the format that you want the result to appear, and then here you mention the variable. If the variable, for example, in this case is float, you mention the float. Okay? Now, the print function has got a specific data format. We have studied this again, but we are going to revise it because it is relevant to what we are studying here. If your format specifier is %d, that means it's integer. %f means a float. %e means a float in exponential format. %g can be exponential format or float format. %c is a single character. %s is a string of characters. And the last one, %l, used with a double or a float to handle long variables. Okay, it can also be long like %lld. Now, look at this program and let's look at the output. So what will be the output in this case? Okay, if I say float value is 65.40, if I mention %f, here it is the output. Exponential format, the output will be like this. Okay, %g, the output will be 65.4, and so on. Okay, so you can try it out. We also have flags associated with our printf. These are some of the flags associated with our printf. Let's see how they work, some of them. Okay? If I say printf result %d, it will show me the integer value. %d means integer value 1977. What if I put 10 before d? Okay? That means show me 10 spaces. Okay? Show me 10 spaces after result. So there will be 10 spaces after result. And then it will show you 1977. What if I put asterisk? Okay. So when you put an asterisk, it means take the next argument as size of the field. Next argument is 10. So the size means 10 spaces from result, which it works. What if I put a 0? That means 0 fill numbers after result. So it will fill up the spaces with 0. Okay. What if I put a plus? That means precede the value with a plus or minus. Okay. And that's what it does. And so on. Okay. Just like printf, which is used to print something on the screen, we also have scanf. What does scanf do? It takes a value from the keyboard and and stores it in a certain place like a variable. Okay, that is why for scanf we have to use the ampersand symbol, which means address of. Whatever the user is entering, take it from the keyboard and store it in the address of variable 1. Store it in the address of variable 2. We studied this in 2 weeks ago when we studied passing by reference, if you remember. Okay, so here ampersand represents address of which variable you're going to store the value. Okay. Besides that, we also have getCharacter function. This function provides for getting exactly one character from the standard input device, which is the keyboard. It takes only one character. Okay. For example, you create a variable ch. Ch is equal to get one character from whatever the user enters on the keyboard and it will be stored here. Just as we have got getCharacter, which is for reading, we have got putCharacter, which is for writing. Okay, so if getCharacter gets a value from the keyboard, putCharacter puts that same character on the screen, the standard output device, which is your screen. So these are some functions. You already are familiar with printf, scanf. Now you're familiar with getCharacter and putCharacter. Now, let's go to the actual reading and writing of file, input and output of file. The first question you have to ask yourself is, hey, why do I need this? Why do I need to read from a file or write to a file? What is the point? I have variables. That should be enough. I create a variable, I store my data in a variable, and I can again get my data from the variable. What is this new problem of creating files and reading from a file, writing to a file? Now, you may realize that your variables are not permanent storage. When you switch off your computer, when your program is not running anymore, your variables are not active. The data stored in them is lost. But once you store data inside a file, it will always be there for future retrieval. Think about the games that you play. Every game you play has an associated score related to your performance. So the score has to be stored inside the game. You may store the score inside a variable, but at the end of the game, when you quit the game, you have to take that score and put it in a permanent file. Otherwise, when you open the game again, your new score will be again 0, right? Because it will not record a previous score. So that doesn't make sense. You have to store data for future retrieval. That is why, my dear students, we have the concept of writing a file on a disk or reading from a disk. Why did I say write first? Because first you have to write, then only you can read. In other words, first you have to do output, then only you can do input. Okay? Remember the concept. Write means output to a file, writing to a file. Reading from a file means getting input from a file. I means read. O means write. Okay, so try to get rid of that confusion. Okay, that is why we do reading and writing. That is why in your assignment also you have this. You have to write to a file and also read to a file. You have to read from a file, it tells you in the assignment. Okay, you have to read from a specific file. Okay, so just keep this in mind, because what we are studying today is going to be implemented in your assignment. Now, remember, everything in our computer is stored in a file. Everything, my dear students. Even when you switch on your file, when your computer looks for a file to load the operating system, the first few files are also a file. The table that is a pointer to where to look for the operating system is also a file. The bootloader is a file. Everything in your computer is a file, my dear students. Without a file, no computing, no matter which platform. Okay? Now, let's understand the concept of files in C programming language. File is a stream of bytes. Okay? C imposes no structure on the file. So you have to tell the C program what kind of file you are creating. Is it a text file? Is it a spreadsheet file? And so on. Okay? Now, you cannot create a file and give it an extension name of, for example, .mkv and expect a movie to be created. It doesn't do that. It's not magic. Or if you create a text file or docx file, a Word document or a Notepad file, you have to have some data inside it. Otherwise the file will be empty. Okay. Now, before you do anything in C, before you create a file, the first thing you have to do is create a file pointer. Now, how do I create a file pointer is the question you're asking. It's right down here. Mention the file and then mention the pointer name. Don't forget to use the asterisk before the file pointer. So right here, I'm creating two file pointers. File pointer 1, file pointer 2. Now, what do these file pointers do? Nothing at this moment, because you have to associate these file pointers to a file. Now, file pointers has to be associated to a file, as well as it has to be told you are for reading or you are for writing. Okay? Over here, the first thing you have to do is you create a file pointer. How does the compiler know this is a file pointer? Because you mentioned the data type file. Just like creating a variable. Mention the data type and mention the variable name. Okay? The same analogy, my dear students. Before you want to do input output in C, you have to create a file pointer. Now, talking about file pointer, let's say I have a text file. Text file, for example, in Windows can be a Notepad file. Okay, look, this is my text file consisting of the words the underscore quick, enter, brown underscore fox, enter, jumped underscore over, enter, the underscore lazy underscore dog. End of the file. Okay? So, when you create a file pointer and associate the file pointer with a file, for example, if you are associating this fptr1 with this text file for reading, then the file pointer will always point to the beginning of the file, something known as BOF, beginning of the file. And when you read it, you see, it starts reading always from the BOF. It reads until it encounters a space or an enter. So it reads until here. Then the file pointer will be waiting here. It reads until it comes to the next line because there is an enter. It reads until it comes to the next pause. Remember, the pauses are created by having enter or a space. You see, here how many pauses do we have? 1, enter, 2, enter, 3, enter, 4. If there was no underscore, then the space would also be a pause. Okay? Remember that. Every time you want to read a file, you have to understand, first you have to open the file, read the file, and then close the file. The same goes for writing. Open the file, write, and then end the file. Okay? Now, file is a sequence of bytes. Now, this is a file, a sequence of bytes. This is also a file, a sequence of bytes. This is also a file, a sequence of bytes. Okay? You have to know the structure of a file. What am I going to store inside the file? You have to tell that to the compiler. Hey, this is going to be a spreadsheet file, or this is going to be a text file, and so on. When you open a file, you have to have a file pointer. And the file pointer should be associated with your file. It's very important to associate your file pointer to your file. Let's say I have a text file. I'm repeating what I told you before, consisting of these 4 words. Okay, the quick, enter, brown fox, enter, jumped over, enter, the lazy dog. When I read this, the file pointer will always point to the beginning of the file, to the beginning of the file. Then once it reads this, then it goes to the next pause, which is after enter. It will point to the next line, then to the next line, then to the next line. Okay? So this is how the file pointer moves. If you don't understand this, don't worry. I'll explain to you in detail so that you understand what I'm talking about. Okay? Another thing you have to understand, if you study operating systems, you will know that reading and writing is not straightforward from the disk. There is always a buffer. Okay? There is a highly fast, speedy device known as a buffer that is between your program and your disk. Okay? So when you want to read, it's always stored in the buffer, and when you want to write, it is always stored in a buffer and then goes on your disk. Now, if you want to open a file, you have to use your fopen function. Okay? You have to first create a pointer. Remember, for reading or writing, the first thing we do is we create a pointer, and then we associate the pointer for opening our file. And when we open our file, we use the fopen function, and we tell, I am opening my file in the read mode, or I'm opening my file in the write mode. You have to tell that, so the compiler knows what you're trying to do. Okay? R means there's going to be input happening, reading happening. W means there's going to be output happening, or you're going to write to a file. So, look at this program. When you open a file, okay, If the file is not found, then we can say that your fopen over here is returning a null. So in this program, we can find out if the file exists or does not exist. Let's do a quick tracing. In the beginning of the program, I am creating a file pointer. Remember, if you are doing input output, you have to create a file pointer. Now the question is, this file pointer is for reading or writing? The next line, I am saying exactly that. I'm saying that my file pointer is going to open a file, mydata.txt, in the read mode. So this file pointer is associated with reading. Next, I'm using an if construct and I'm saying that, hey, if my file pointer is null, that means my data.txt is not found, and display on the screen file my data.txt did not open. Okay, a simple plain program. If the file pointer is null, that means the file does not exist. That is why it's very important for you to remember, always you have to do writing, then only reading. You cannot read something that does not exist. Another example, look over here. When you read from a file, when you read something from the keyboard, you use scanf. You already know that. When you read from a file, you use scanf function. Okay, just like scanf, but reading from a file. Okay, now look, I'm creating two variables, I'm creating two variables, A and B, and then I'm creating a file pointer, fptr1, and I'm saying that this file pointer is associated with reading a file, mydata.txt. Here is mydata.txt file consisting of two numbers, 23 and 102. Now, next I do the file pointer. I say, hey, if my fptr is null, show that file mydata.txt does not open. It cannot be null because the file is right over here. So it goes to else. And then it says, read from the file. Since you're associating fptr with mydata.txt, the file pointer will always start with the beginning of file. So here I'm saying fscanf, that means read from my file. fptr points to mydata.txt. Read from the file. The first value, remember, beginning of file 23, then space. So 23 will be taken and stored inside a variable. Remember, a variable you created here. And then after the space, 102 will be taken and stored in the B variable. Either space or enter should separate your values. If I did not have a space here, guess what happens? Then 23,102 will be stored in A and nothing will be stored in B. The file pointer will just read it and come to the end of file. Get the idea, my dear students? That's how it works. That is why, in order to separate your values, you should either have enter or space. Once you have stored 23 in A and 102 in B, then you can use printf to display it on the screen. Now, I want you to look at this program carefully, okay? I'm going to do tracing on this program so you understand the whole concept. It's very important for you to understand this, okay? Can someone confirm that they can hear me? Anyone? Please open your microphone and confirm.
Yes, sir.
Okay, thank you. Now look at this explanation. This is the crux of today's lecture. I'm doing a tracing on this. I'm going to the details so that you also do tracing and understand the concepts. The file name is mydata2.txt consisting of these values, okay? 5, enter, 23, space, 75, enter, 92 space 102, enter. 111 space 9, enter. 25 space 203, enter. 777 space 93, end of file. BOF, EOF. Beginning of file, end of file. Okay? Now these numbers are straightforward and you can see them. What you cannot see is the enter. The space also can be seen. The enter is not visibly clear, but you should know that after 5, there is an enter, then there is number 23, then a space, then 75. Remember, when you are reading, the pointer will read a constant value until it encounters an enter or a space. Now let's do a tracing on this program. In order to do my tracing, this is the place I am going to mention my variables, and this is my output. Okay? Now the program starts from the beginning line, I, variable. Okay? Next, I have created 3 more variables, number, A, and B. Here it is, number, A, and B in the next line. Okay? I'm doing a tracing, please pay attention. This is how you do tracing when you are learning programming. Okay? Next, I create a file pointer. The name of my file pointer is fptr1. The moment you write this line, your compiler knows, hey, this program is going to be a reading or a writing program. Next line, I say, hey, this is going to be a reading program associated with the file mydata2.txt. So the pointer that you created in the previous line is immediately linked, joined to mydata2.txt. So this pointer is married to this file. What does that mean? That means the file pointer will be here at the BOF, the beginning of file. You see over here? Your file pointer will start over here. We'll be waiting for some action to happen, depending on what you ask it to do. So your file pointer will be here, right after this line, associating the file pointer with this file in the read mode. So it will be over here, waiting for instructions. Next, you are saying, hey, fscanf, that means I want you to read from the file. fptr is associated with mydata2.txt. So fptr will read the first value. What is the first value? 5. It will read the first value and store it in the variable number. You see, right over here. I want you to read from the file and store whatever you're reading inside the variable number. So it takes 5 and stores it inside number. Okay? There. The value of number is 5. Now ask yourself, why did we give 5 to the number variable? The reason is, when we want to read 5 rows. 1, 2, 3, 4, 5. That is why it started with 5. Okay? Moving on. Next, we go to a for loop. Okay? Sorry, I forgot to tell you. After it reads the value 5, the pointer doesn't just stay here. After it reads the value 5, the pointer moves to the next pause, which is a enter. So the pointer comes over here. So the pointer will be waiting over here for the next instruction, which goes to the for loop. What happens in the for loop? We say I is equal to 1. I is a variable is equal to 1. There we have initialized I to 1. Next, we say I is less than or equal to number. Number value is 5. 1 is less than 5. True goes inside the for loop. The for loop opens here and ends here. Since this is true, goes inside the for loop to this line of code. What happens in this line of code? I'm saying that, hey, I want you to read. fscanf means read from file, mydata.txt. I want you to read the two values, you see, separated by a space, and store them inside A and B. So 23 will be stored inside A. And then the file pointer will move to the next, because there is a space. The file pointer will move to the next place. Remember, the file pointer will read everything until it encounters a space or enter. So the file pointer will be waiting here, and then it will read 75 and store it in B. Once it reads 75 and stores it in B, it will move to the next place, which is right over here. Okay? And then using printf, I'm saying I want you to display on the screen A and B separated by space. So 23 and 75 will be displayed on the screen. After that, what happens? We come to the end of the for loop. It goes over here, I++. The value of I is 1. 1 plus 1 is 2. I value changes to 2, goes back to the condition. The condition says I should be less than or equal to number. 2 is less than or equal to 5. True, goes inside the loop again. Again, we are reading scanf, store the value and store it in A and B. So it takes the value of 92 and stores it inside A, and 102 and stores it inside B. So these two old values will be overwritten to 92 and 102. The moment it reads 92 and 102, the file pointer, the cursor, file pointer, whatever you call it, goes to the next pointing value. It will be waiting over here. Okay? Next, you are saying printf. On the screen, show me the value of A and B. So on the screen, it will show you 92 and 102. Again, I++. Okay? I++. That means 2 plus 1. The value of I will change to 3. Now the question is, it goes back again to the condition. The question is I less than or equal to number? I value is 3. Is 3 less than or equal to 5? Yes, true. Goes inside. Again, scanf. That means read from the file. File pointer fptr is pointed to mydata.txt, mydata2.txt. So read from the file mydata2.txt and store the values in A and B. So where's the cursor? The cursor is here. So it will read 111 and store it inside A, and 9 and store it inside B. So these values will be overwritten to 111 and 9. The moment you read these two values, guess where your cursor goes? It goes right over here, the next place. Okay, it will be waiting for your next instructions. After that, the next line of code, printf, that means show me on the screen the values of A and B. So 111 and 9 will be shown on the screen. Since it's a loop, it always goes back to the reinitialization, I++. I value is 3. 3 plus 1, the value of I will have a new value, which is 4. Next, it goes to the condition. The condition says 4 is less than or equal to number. Number value is 5. 4 is less than or equal to 5. Condition is true, goes inside the loop. And in the loop, you say, I want you to read from the file and store the values in variable A and variable B. So the cursor is here. So it takes the value 25, stores it inside A, 203, stores it inside B. So the values of A and B will have new values, 25 and 203 respectively. Okay? Next, once the cursor has read these two, the cursor will move to the next line and wait over here. In the program, you say, next line of code, printf A and B with a space. So the value of A is 25 and the value of B is 203. So it will print these two with a space. Since it's a loop, once it comes to the end of the code, it goes to the reinitialization. In the reinitialization, we say I++. I value is 4. 4 plus 1 is 5. So the new value of I is 5. Next, from here, it goes to the condition. Remember a loop. Okay, this condition will continue. This loop will continue as long as the condition is true. The condition is I should be less than or equal to number. 5 is less than or equal to number. 5 is not less than number, but 5 is equal to number. Okay, so in this case, it's true, goes inside scanf, okay, read from the file mydata2.txt and store it in A and B. So the cursor is here. 777 will be stored inside A and 93 will be stored inside B. So the values will change to 777 and 93. Once it has read this, you see there's no more enter. The cursor will come to a place known as EOF, end of file. Remember where the cursor was? It started with BOF, beginning of file. Now it is at EOF, end of file. Okay, and it stays there. Next we say, show me on the screen, printf A and B. So the value of A and B will be shown on the screen. Since it's a loop, it goes back to the reinitialization, I++. 5 plus 1 will become 6. The value of I changes to 6. Then it goes to the condition. Condition says I should be less than or equal to number. Is 6 less than or equal to number? True or false? 6 is less than or equal to 5. Number value is 5. 6 is less than or equal to 5. False. Since it's false, it gets out of the for loop. For loop begins from here, ends over here. Since the condition is false, it gets out of the for loop. And here, what you do is you close the file pointer. Remember, first you create the pointer, then you associate the pointer in read or write mode to a file, and at the end, you release the memory and you close the pointer. So that's how this program works. Okay? This is how you learn programming. By doing this, my dear students, every single program you encounter, do this. Do tracing. You will learn programming very well. Now, as I told you before, we have an end of file and we have a function which can find out whether you have reached the end of file. Okay? And that function is FEOF. We have got another way also that we can find out whether you have reached the end of file by using the function fscanf. Let's have a look at it. One way of finding out whether you have reached the end of file. Okay? So let's say I use fscanf and I store the value inside a variable var, where whatever it reads. Now if I say if FEOF of this file pointer, that means if the file pointer is pointing to the end of file, then print end of file is encountered. This is one way of finding out where is the end of the file. Another way is by using fscanf. You see, I create a variable I status. I say I status is equal to read from a file and store it inside a variable. Now, if I status is the same as EOF, then end of file is encountered. So you can use this way or this way. Now the question is, why do we need to find out where is the end of the file? I'll tell you why. Look at this program. This is the same program like the previous one, except if you see over here, in the previous program, you see you had 5, which tells you, you take the value 5, you know that you have to go inside your file 5 times 1, 2, 3, 4, 5. That's why you say I is less than or equal to number, which is 5. But in this program, there's no 5 up here. Can you see that? Since there is no 5, how will you know when to stop? The answer is by finding out where is your EOF. Keep reading until you encounter EOF. Look at the condition. It's a do-while loop. Remember do-while loop? In a do-while loop, the statement comes before the condition. So it will execute at least once. So every time it goes and reads, it comes to the while loop and you say, hey, is I status value not equal to EOF? If this is true, then do another reading. Okay? If this is false, then get out of the loop. So the moment it encounters an EOF, that means I status is equal to EOF. Then it gets out of the loop and closes the file. So you can either do it in this way or in this way. Here, you have to mention a number which denotes how many rows you have. Here, no need to mention any number. It will keep on reading the rows until it reaches the EOF. Okay? Just as we can read from a file, we can also write to a file. The same concept, my dear students. Create a file pointer, and when you open the file, associate it with writing. Now, FPTR2 is associated with writing. Okay? And every time you open a file, don't forget, every time you create a file pointer and associate it with a file, you have to also close it so that you release memory. Okay? Now, let's look at this program. What am I doing? I'm creating a file pointer. I'm associating my file pointer to a file known as mydata.txt. And the association is in the read mode. So I'm going to read. Next, I say if FPTR is equal to null, okay, show me that the file does not exist. Since the file exists, this will be false. It goes to else, and then it reads. The file pointer is associated with mydata.txt. Reads the first value, 23 will be stored inside A. Then there is a space, 53 will be stored inside B. Okay? And then, using printf, I can display it on the screen. Since R is associated with reading, we can replace it with, for writing, we can replace it with W. Okay? So, when you say, open my data, and say W, that means, hey, now I'm going to do a writing operation. I'm going to write data. Okay? Now, when you are reading, you use fscanf. That means, hey, I want you to read from a file. When you are writing, then you use fprintf. That means I want you to write to a file. That means write to my data the value A and B. What is the value of A and B? 5 and 10. Put it inside the file without a space. Okay? Now, we also have a function known as getc. This function is similar to getCharacter. The only difference is the input can be from the keyboard or a file. This is for reading. We also have for writing putc, similar to putCharacter, except the output can be to the screen or a file. Okay? In this program, I am writing and then reading from a file. Remember, always you have to first write and then you have to read. First writing should happen, then reading. So look over here. What I do, it's the same program. I've made it bigger. I create two file pointers, out file and in file. Two file pointers, okay? And I create other variables as well. Now, my out file pointer is associated with testdata.txt in the write mode. And then using fprintf, what I do is the testdata.txt, I write inside the file, I write the value, okay, the first value that I write is a value. What is a value? 13.72. So that will be written, okay, in 2 decimal places, 6 spaces from the left. After that, 2 spaces put b. B value is 5. Okay. After that, 5 spaces, I want to write the C value. C is 6.68 in 2 decimal places. So this value will be written to a file, testdata.txt. And then I close out file, file pointer. Okay. Next, I open testdata.txt in the read mode. I associate in file, file pointer with testdata.txt in read mode. And now I read the data and store it inside E, F, and G. Okay, there, F, E, and G. So the value of 13.72 will be stored in E since there is a space. 5 will be stored inside F since there is a space. 6.68 will be stored inside G. And then I use fprintf and display this on the computer screen. And once I'm done displaying on the computer screen, I close the in file, file pointer. That's it. A program that does both writing and reading. Now, so far, we were interested in doing reading and writing on a text file, a notepad file, or a document file, and so on. Here, we will look at how to generate a comma-separated value file. In other words, how to generate a spreadsheet, okay? Like an Excel file, okay? A comma-separated value file, each column will be separated by a comma, okay? Now look at this program. In this program, what I'm creating is a file known as sign.csv. That means I want to generate a spreadsheet file. Let's look at the details of this program, okay? I create 3 variables, degrees, sine, and cosine, okay? Another variable, degrees to radians, divide pi by 180. And then I create a file pointer known as output. The file pointer can have any name you want, okay? Then I say output file pointer is associated with a file sign.csv and it is in write mode. That means I am creating a file sign.csv in the write mode. The moment the compiler comes over here, a file is automatically created known as sign.csv. Like magic, sign.csv is created. It's a spreadsheet, okay? Automatically it's created. But the thing is, it's empty inside. There's no data inside, okay? Now, how do I fill it up with data? You see, I say fprintf. That means I want you to print, okay? Inside, output is associated with sign.csv. Remember, we did the association here. Output pointer, I want you to write angle in the first column. Remember, comma means separate column. Angle, sine, and cosine. So the first 3 columns will be angle, sine, cosine. That's what happens over here in this line. Next, we start a for loop. I say degrees Remember degrees? You created this variable here. Degree is initialized to 0.0. 0.0 is less than or equal to 360.0. True or false? True. Goes inside the loop. Calculate the sine value. Calculate the cosine value. Okay. Use the formula. And then, again, write to the file. Remember, after you have written to the first row, then the file pointer will be waiting over here. Okay. So I want you to write the first values, okay, of degree, sine, and cosine. I want you to write inside my output is linked to sine.csv. Since the file pointer is here, it's going to write these values right over here. Next, degrees increment by 10. So from 0, it will be 10. 10 is less than or equal to 360. True. Goes inside, calculates the value of sine, calculates the value of cosine. And now, for 10 degrees, it will show you the sine and cosine inside the third row. And then increment by 10. 10 will become 20. And so this loop will continue until it gets out of the loop. So it will continue until 360. It will get out when this becomes 370. So this loop will continue and show you all the values of the angles sine and cosine. Okay. Now, I would like to show you how this program works. I'm going to run this program. Look, I have a file, a dev C++ file. You don't see any spreadsheet over here, do you? Because I haven't run the file yet. Now I'm going to run my file. Look, it's the same program. I'm going to press F11 and compile it. Okay? You don't see any CSV file over here, no spreadsheet file. But when I run my program, okay, when I press F11 to compile and execute my program, the program doesn't show any output here, but it creates a file. Okay, press any key to compile. So when I go back again to the place that I stored my program, you see, there, it has created my sine.csv. Okay, and when I open, I can see the data inside it. Okay, so that's what it does. So today we learned about input and output, standard streams, files, and how to generate a CSV file. Now you're going to take that information and you're going to solve your lab exercises and implement the solutions inside your assignment. Okay? Hold on a minute.
Excuse me, sir.
Yes.
I have a question. If we don't create a file, like let's say if we don't create a CSV file, then we write into it. But if we generate one from the program, will it overwrite every time will everything be overwritten every time you run the program, or is it by the different modes?
Yes, it will overwrite. Every time you write, it will overwrite.
Okay.
Okay. There is a way, you see, there is a file pointer always starts with a BOF, correct?
Yeah.
That is why it will overwrite. Now you have to learn how to make sure that when you open a file, it doesn't start at BOF. You move it to a place where you want to start writing. Get it?
Yeah.
That
Understood.
information is not given to you because it's beyond your course. When you study computing, perhaps you will. Actually, it's just a function where you can move it. It's not a big deal. Okay. Any other questions, my dear students?
Not currently.
Okay. Anyone else? Wow, today we have got good attendance. What is it? 25 or 30 students? Yeah. Uh, Remember, my dear students, your assignment is coming very close to submission. So please pay attention to it. And um, again, this video, I will upload it to Moodle. Have a look at it. Last week's video, I haven't uploaded yet because it's got some problems. I'm updating it, and I will upload it by in 2 days' time. Okay, along with this. So please have a look at it. Hopefully, it will help you when you do your assignment or your lab exercises. Um, Next week will be our last lecture where we are going to do a revision. So if you're available, please join the session. Okay. Anyone has any other questions that they want to ask? If not, then we stop the session. Okay. Thank you very much for your attention. I'll see you all next week. Bye.
Bye.